Hi, I have some really cool evidence for you for the Big Bang. Three great strong pieces of evidence just to move you forward in a general chemistry class. Okay, so number one piece of evidence is that there's this commonality in our elements in the universe, and the number one element, the most abundant element, actually 74% of the universe, it's made up of hydrogen. So it tells us that the universe is made of the same building block, that there was that moment where that pearl exploded and the very smallest building blocks, that those came together to form hydrogen. So 74% of the universe is hydrogen, 24% of the universe is then the fusion of hydrogen to make helium. So 24% of the universe is helium. And then the rest of the elements, so this is going to be lithium through uranium, atomic numbers 3 through 92, they make up the remaining 2% of all of the elements. So there's going to be your first piece of evidence, is that there's this similar building block, the initial building block that came from the Big Bang, and that was hydrogen. Now, while we're here, I want to talk just a little bit about the idea of commonality of elements and the significance of how that impacts Earth. So all the elements that are seen, that are observed in the universe, numbers 1 through 92, helium through hydrogen through uranium, they are also found on Earth. And so we have the same elements on Earth and the universe. Now, our elements 93 through 118, we've made those. Those are all man-made, and we haven't observed them anywhere in the universe. So elements 1 through 92, those are naturally occurring elements found naturally on planet Earth and throughout the universe. And then numbers 93 through, and that's going to be our, let me look really quick here, Neptunium, through our 118. Those are man-made. Those are all the man-made. Interesting point. Earth has an unusually high abundance of heavy elements. So let's compare. The most abundant element on Earth, 46% of Earth is comprised of oxygen. Now compare that to the universe, 74% is hydrogen. The next most abundant, silicon, 28%, aluminum, 8.3%, and iron, 5.6%. Now these four elements, the most abundant elements on Earth, those are in the 2% of the rest of the universe. So just wanted to contrast that, kind of interesting. Yes, we have the same elements in the universe that we have on Earth, but Earth has kind of a flip-flop in abundance. Our abundance, highest abundance, sits in that 2% right there. Just thought that was interesting. Just happens to be that we have a high abundance of heavy elements. Okay, so number one piece of evidence, 74% of the universe, hydrogen, the same building block, came from the Big Bang. Number two, redshift galaxies, and we can thank Hubble for this, that he discovered these redshift galaxies. Redshift galaxies, in a nutshell, is that as we look at the furthest, deepest part of the universe, we can tell that the farthest galaxies are moving farther and farther and farther away from us, and that is called the redshift. Now, the universe, we can tell from these redshift, these galaxies moving further away from us, they're moving at a rapid rate. In fact, the rate at which they travel, if we could set a ball in motion to go around the Earth at the same rate that the universe is expanding, that ball would travel around the Earth 156 times in one day. The ball would go around the Earth 156 times in one day. That's how quickly the universe is expanding. So I want you to picture a point as if it's a balloon. Okay, we're going to start blowing up this balloon, and it blows up like this, gets bigger, bigger, bigger. That's the universe, and it's expanding. We can tell that it's expanding from a point of origin, and that was the Big Bang. So the universe is expanding. Also, just a fun, I love studying this, fun little side note is that the expansion, the rate at which the universe is expanding is precise to maintain life on planet Earth. If the expansion rate changed even a small, tiny bit, I mean even like inches, 2 inches, life could not exist. Life on planet Earth would not exist. So amazing, the precision of the universe. And one example, there's like 30 different physics constants in the universe of precision in order for life to exist. One of them is the expansion rate of the universe. Kind of cool. Okay, I'm going to end with my favorite part, piece of evidence for the Big Bang, and this is going to be cosmic background radiation. So I want to tell you a really quick story. This was in the 1960s, Bell Laboratories. There was a scientist that it was his goal to get the purest sound possible, no background static at all, listening to the universe. If you haven't, Google NASA's listening to the sun and our different planets. They're beautiful. They sing. The planets sing. What it is radiation is being released, and radiation is from radio waves to gamma waves. Well, if we tune in to those larger waves, we can hear it. It's audible. So this scientist from Bell Laboratories was trying to listen to the universe, but take out all background noise. And so I went to great lengths, and there was an issue. There were birds, pigeons, that would nest around his satellites. And so he decided that he was going to clean them up. He moved them like hundreds of miles away, washed everything, and then tried to listen, but he still had background noise. Well, the birds had come back. So second round, he euthanized those birds, okay? So no birds, everything's clean, and guess what? He still has background noise. Well, there was a common friend on the East Coast in the United States that had a friend in Europe, and the colleagues in Europe had been working on a theoretical problem. Here was their idea. Okay, light, if it came into existence at 300,000 years, so when the universe was 300,000 years old, there should be evidence of it. Hence the word cosmic background radiation. There should be evidence of it. And so visible light, we know that that's in the nanometer range. As the universe expanded, time and space expansion, that wave would have expanded, and they figured that it would have been about a meter long, okay, so through all their mathematical calculations. So this common colleague on the East Coast connected Europe and Bell Laboratories in the Midwest, and come to find out that noise, that static that the scientist was hearing was actually the echo of light. It was that 3-foot wave that's in the audible range. So when you and I, just for fun, you might not even listen to the radio anymore. I want you to turn on the radio. I want you to change the stations, and I want you to hear that static that you hear. 0.3% of what you are hearing is the echo when light came into existence. That light wave has now stretched, and we can hear it. You can hear evidence of the Big Bang. Does that make you excited? It makes me excited. I think it's so, so cool. So there you have it. Kind of fun. Evidence for the Big Bang Theory. Enjoy it. If you want an overview of the Big Bang, more nuclear, take a look at my playlist on nuclear chemistry, leanthink.org. Thanks. Bye.